Embracing the microservices architecture, a journey through distributed systems. In today's ever-evolving technological landscape, an architecture that has rapidly gained traction is undoubtedly microservices. This term may sound elusive to some, but its concept and potential are vastly transformative in the realm of distributed systems. As we delve into this intricate world where small autonomous services coexist harmoniously, it becomes evident why many organizations across industries have embraced microservices as a key part of their digital transformation journey. The essence of microservices lies within its name, micro. It is an architecture style that enables the construction of complex applications by breaking them down into small, loosely coupled services. These services are fine-grained functionalities bounded by well-defined interfaces, making it possible for developers to build and evolve each service independently without affecting others. Microservices have revolutionized how we approach software development. However, their emergence has not been a sudden phenomenon, but rather an evolution from previous architectural patterns such as monolithic systems. The history of microservices can be traceable back to the early days of web services and so, when businesses started to realize the value in leveraging modular, interoperable components for their applications. Over time, a need arose for more flexibility within these systems, as organizations began exploring cloud computing and DevOps practices that advocate rapid iteration and continuous delivery. This quest for agility gave birth to the microservices architecture we now know today. However, it also brought forth new challenges that needed addressing in order to fully capitalize on its benefits. One of the most significant advantages offered by a microservices approach is scalability. In traditional monolithic systems, scaling typically involves increasing resources for an entire application, since they cannot be isolated into separate services. This can result in over-provisioning and unnecessary costs. On the other hand, microservices enable individual components to scale independently based on demand, enhancing resource utilization while maintaining performance levels. Another advantage is resilience. Since each service operates autonomously with its own dependencies and error handling mechanisms, failure in one part of a system doesn't necessarily impact the entire application. This isolation helps organizations better manage risks, as well as quickly identify and resolve issues within specific services without disrupting overall operations. Microservices also promote technological heterogeneity, allowing teams to select different languages, frameworks, or database systems that are best suited for their respective service requirements. It empowers developers by providing the flexibility needed to leverage expertise and innovations in various domains while maintaining cohesive functionality across services. However, adopting a microservices architecture is not without its challenges and potential pitfalls. The complexity that comes from managing numerous small-scale components can lead to increased operational overheads such as monitoring, logging, and governance. Additionally, network latency becomes an issue due to the need for services to communicate with one another through various channels, which may result in performance bottlenecks if not handled properly. Moreover, building a distributed system based on microservices requires significant changes in organizational culture, from how teams collaborate to adopting new methodologies such as DevOps and continuous integration, continuous deployment. The transition process can be arduous for businesses that are deeply rooted in traditional architectural practices. In conclusion, the microservices architecture is an innovative approach to distributed systems that has gained significant traction in today's digital age. Its ability to promote scalability, resilience, and technological diversity makes it a compelling option for organizations seeking agility and in rapid adaptation within their software development processes. However, while microservices offer numerous advantages, they also present several challenges that must be considered before implementing them in any system, design, or architecture plan. As such, businesses should carefully assess whether the benefits of adopting this approach outweigh its potential drawbacks based on their unique requirements and constraints. Despite these concerns, there is no doubt that microservices are here to stay, evolving and maturing as organizations continue to uncover new ways to harness their power in order to build robust, efficient, and adaptable digital infrastructures capable of meeting the demands of tomorrow's business world. The journey into microservices architecture may be complex and challenging, but it holds the promise for a future where distributed systems thrive and organizations remain agile, competitive, and ready for whatever comes next.